In the previous video, we saw that the production cost relationships in their most basic form look like this. Total cost is divided into fixed costs and variable costs. The fixed cost function is a horizontal line and the variable cost function is a positively sloped line. The total cost function is also a positively sloped line that is vertically parallel to the variable cost function. The difference between the two is fixed costs. In this video, we want to focus on the variable cost function. Specifically, is it really a straight line as indicated here? If not, what will be the forces that will cause it to actually curve? What will be its shape? And how will it affect the shape of the total cost function? First, let's consider what will cause the variable cost function to actually be curved. In reality, there'd be too many to mention, but they'd all fall under the category of the law of variable proportions. The law of variable proportions, you will recall, consists of two phenomena which are the obverse of one another: the law of diminishing marginal returns and the law of increasing marginal costs. These two graphs illustrate both concepts. This first graph illustrates that as inputs increase, so does output, but at a decreasing rate. There you can see the marginal or incremental output, or as an economist would call it, the marginal product of each additional increment of input is declining. This graph on the right shows that as output increases, so does total cost, but at an increasing rate. The marginal cost of these additional units of output are rising. Before we go any further, let me identify these curves. This one, which shows the relationship between input and output, is called a production function. It's important to note that this function assumes that only one input is changing. In this case, it would be labor. Everything else, such as the factory size, the productivity of the tools, and other capital equipment, etc., remain the same. It's positively sloped, indicating that as you add more of that particular input, ceteris paribus, you get more output. It's flattening out because of diminishing marginal returns. This, of course, is a variable cost function. It is also positively sloped for obvious reasons, but it's rising at an increasing rate because labor is becoming less productive due to diminishing marginal returns, shown there in the production function. Because labor is less productive as more workers are added, for whatever reason, in the case of the grave diggers, you'll recall it was crowding, it takes more of an input to produce a unit of output. The fact that the variable cost function is rising at an increasing rate results from the fact that the marginal cost of additional increments of output is rising. So now, looking at our cost relationships, we see that the variable cost function will rise at an increasing rate, expressing the increasing marginal costs of output. The fixed cost function, notice, is still a horizontal line. It is unaffected by the law of increasing marginal costs. But before we look at the effect that the shape of this variable cost function will have on the shape of the total cost function, we need to consider another phenomenon. This phenomenon is known as increasing marginal returns. It's not a law, as is the law of diminishing marginal returns, because it doesn't always happen. But it happens frequently enough that we need to consider it in this scenario. Let's imagine an individual, we'll call him Mr. A, starting his own widget company. He or she begins with a very small factory about the size of somebody's garage. He uses a set of tools, perhaps an electric saw, a hammer, a screwdriver, as well as wood and plastic and glue and other things to produce the widget. In addition, he must make the phone calls trying to sell them. He also has to transport the widgets in his truck to wherever they need to go. Then, later in the day, he needs to clean up the tools and the factory and then start working on the books. He needs to enter values into the income statement and balance sheet. He needs to pay the bills and order new materials. In other words, he needs to be a jack of all trades. Let's keep track of the productivity of this factory. Let W stand for the number of workers, and let Q stand for the quantity of widgets produced. It's obvious that he's going to be better at some things than he is at others. Maybe he's a really good widget maker, but not so good with the books. Or maybe he doesn't have a pleasant phone manner or not good at selling. Plus, as his business expands, he continually falls behind on some of these other tasks. Maybe he's late paying his bills or continually puts off cleaning up the factory. It's obvious that he's going to be better. Clearly, he's going to need some help. Let's say that he hires someone, we'll call him Mr. B, who has a good knowledge of bookkeeping, has a pleasant phone manner, is a good salesperson, and excels at cleaning up the factory. This would permit Mr. A to focus entirely on making widgets, the skill at which he excels, and relieves him from all of these other tasks at which he's not so great. Now, originally, it would take him half a day to perform all of these tasks that don't directly contribute to the stock of widgets produced. But the new person he hires can do all of these things in a couple of hours and spend the rest of the day helping Mr. A produce widgets. Let's suppose then that Mr. A, working by himself, given all of these other tasks that he has to perform, can produce 10 widgets in one period. Let's call it a day. So now Mr. A has an extra half day to produce widgets, meaning that he can produce another 10. Mr. B takes only 2 hours to do all of these other things, whereas it took Mr. A half a day, so he can use the next 6 hours to help Mr. A produce widgets. Assume that in that 6-hour period, he can produce 6 widgets. He's not as productive as Mr. A because widget production is not his specialty. Mr. A can produce 20 widgets in an 8-hour period. That's more than 2 widgets an hour. But Mr. B can only produce 1 widget per hour. So the 2 workers working together can produce a total of 26 widgets in one day. So it would be wrong to say that Mr. B himself added 16 widgets to total output. Those 26 widgets are the result of the collective efforts of Mr. A and Mr. B. However, it would be correct to say that the addition of Mr. B added 16 widgets to total output. As you can see, that as a result of specialization, marginal product rose from 10 to 16. We could call this phenomenon increasing marginal returns. In the essay entitled Introduction to Capitalism, in the course content lecture notes section, which you have already been assigned in a previous module, you learned the 3 ways in which specialization increases productivity. So, as a firm begins to add more and more workers and produce more and more units of output, it might benefit from the specialization of those workers. However, there's only so much increased productivity you can get out of increased degrees of specialization. So at some point, the benefits of specialization will begin to decrease. As more and more workers are crammed into the factory in order to produce more output, some on the phone, some cleaning up, some specializing in this or that task, it seems that the space would start to get very crowded. Once it becomes too crowded, worker productivity would begin to fall and output per unit would begin to diminish. This we can now identify as the law of diminishing marginal returns setting in. Let's now look at the complete production function with both increasing marginal returns and diminishing marginal returns shown. In the first part there, where the production function is rising at an increasing rate, this shows that marginal returns are increasing as a result of specialization. And here, the production function begins to flatten out, showing that marginal returns are diminishing. In our example, this was due to crowding. Here's a situation that we could ignore right after this, but it's worth mentioning here. This segment of the production function is actually turning negative. This indicates that total returns, not just marginal returns, are diminishing. In our example, we might imagine that there are so many workers packed in the factory like sardines that they're trying to perform their tasks with their arms pinned to their side. We could ignore this from this moment on because no profit-maximizing entrepreneur would permit this to last for very long. Here's the situation. Here then is a complete picture of our variable cost function. Notice that in the beginning, variable costs are rising at a decreasing rate, indicating that marginal costs are falling as marginal returns are increasing. And in this segment of the variable cost function, variable cost is rising at an increasing rate, indicating that marginal costs are rising. And that's because marginal returns are diminishing. And there's the complete variable cost function without all the flotsam and jetsam. And there's the fixed cost function. So now we are ready to add the total cost function. But what does that look like? Keep in mind that the total cost function is vertically parallel to the variable cost function, and the distance between the two is fixed costs. We know that the starting point for the total cost function is the point at which the fixed cost function intersects the vertical axis. And from there, this will be the vertical distance between the total cost function and the variable cost function. So there's the total cost function. Notice that all of those arrows are of equal length. The total cost curve is vertically parallel to the variable cost curve, despite the fact that the two curves don't look like railroad tracks. Technically speaking, in order for the two curves to look like railroad tracks, the distance of the arrow drawn perpendicular to the tangent of the curve would have to be equal. But you don't have to know that for this class. Here are the relationships you need to know for this class. However, these aren't the curves that we'll actually be using while modeling the behavior of the profit-maximizing firm. For our models, we'll need to derive the average or per unit cost relationships from these total cost relationships, and that's what we'll be doing in the next video. Here are the relationships you need to know